Welcome to The Explainer. Today, we're going to crack open a really fundamental idea that's going to totally shift how you think about logic and meaning. It's kind of like a hidden language, one that works way beyond a simple true or false. So let's just dive right in with a little puzzle. You see two statements here, 1 + 1 = 2, and the Earth is round. I mean, we all know they're both true, right? No debate there. But here's the real question. Are they the same? Do they actually mean the same thing?
In the world of classical, old-school logic, the answer is, well, yeah, kind of. And that answer, right there, shows us a really fascinating limitation, a sort of blind spot that we were going to dig into.
And this whole thing leads us smack into what you could call the two-value trap. It's this foundational piece of classical logic that creates the very puzzle we're looking at.
So in this classical world, every single statement has to fit into one of two boxes. It's either true or it's false. That's it. There's no room for nuance, no gray area. It's a totally black and white world.
So where does this idea come from? Well, it's all built on something called Frege's principle. The idea is basically that sentences are just names. Any true sentence you can think of, whether it's about math or planets or what you had for breakfast, is just another label for the big abstract concept of true.
Think about it like this. You've got this really basic coin sorter. You drop in a quarter, you drop in a dime, you drop in a dollar coin, and they all just clunk into the same bin labeled valid currency. The sorter doesn't care about the difference between them, it just cares that they're real money. That's exactly how classical logic treats our two true sentences.
Okay, so how do we get out of this trap? How do we build a logic that's actually smart enough to tell the difference between the quarter and the dime? Well, the answer means we have to jump to a totally new way of thinking.
And that's where non-Fregean logic makes its entrance. And you can probably guess its first move, right? It totally rejects Frege's principle. It makes this pretty radical claim that sentences have a meaning, a reference to something out there in the world, what logicians call a semantic correlate, and that this meaning is totally separate from just being true or false.
And this changes everything. We're adding a whole new dimension here. Suddenly, a sentence isn't just a boring label for true, it's a pointer. It points to a situation, an idea, a state of affairs. It actually has a reference.
All right, so if we're going to add this whole new layer of meaning, we're going to need a new tool in our toolkit, right? How do we actually, do anything with it?
The key, it turns out, is a new kind of logical operator. And this idea was just perfectly captured by the logician Roman Susco. He basically said, hey, we need a way to say that sentence A and sentence B are pointing to the exact same situation. And that tool is this, the identity connective. Yeah, it looks just like an equal sign, and that's because it kind of acts like one, but for meaning. It lets us ask a much deeper question. Not just, are these sentences true, but do these sentences refer to the same underlying reality? So now, look at what we can do. Our analysis has two whole layers. We still check if something's true or false, of course, that's still important, but now we can also analyze what it refers to. This gives our logic a kind of depth and precision that was just impossible before.
So what really happens when we plug in this new tool? What does this new power unlock? Well, as it turns out, the expressive power doesn't just go up a little bit, it absolutely explodes.
All of a sudden, this huge range of other logics, things that were considered non-classical, they can all be understood inside this one single framework. We're talking modal logics that deal with possibility, or even paraconsistent logics that are built to handle contradictions. The whole shebang. They all find a home here.
I mean, the power here is so huge that you can use it to map out entire branches of super abstract math. You can take these deep, fundamental structures from fields like group theory and translate them directly into this logic of meaning. It's wild.
Actually, get this. This logic is so powerful that some versions of it are what's called undecidable. Now, that might sound like a bad thing, right? But in logic, it's actually the opposite. It's a sign of incredible strength. It means the system is complex enough to ask questions that are just too big for any simple computer program to ever solve.
Okay, so let's pull all this back. What's the big takeaway here? Why should we care about this kind of abstract logical idea? Let's break it down. This table really lays it all out, doesn't it? You've got Fregean logic, where the only thing that matters is the truth value. Sentences are just names for true or false. But then look at non-Fregean logic. We add meaning. Sentences become pointers, which lets us ask that way deeper question. What does this actually mean? So here's the bottom line. It's an upgrade, a massive one.
Non-Fregean logic takes our reasoning from being like a simple on-off switch to being like a high-resolution lens. It's a lens that lets us see all the rich, complex texture of meaning in our language and in our own thoughts.
And that leaves us with one final kind of mind-bending thought to take with you. If we now know that the basic rules of logic aren't set in stone, that we can actually upgrade them, it really makes you wonder, right? What other invisible rules, what other silent languages are shaping the way we think every single day without us even realizing it?